Hello everyone. Now I'm going to explain the shortcuts of finding horizontal asymptotes. There are some basic ways of finding horizontal asymptotes which you studied in grade 10. You'll probably remember. It's about the degrees of the polynomials, degrees of the function at the top and degree of the function at the bottom. If degree of the function at the top is more than degree of the function at the bottom, then there will be no horizontal asymptote. If degrees are same, then we will just take the ratio of the coefficients, and if degree of the top is less than degree of the bottom, we will say y equals 0 is the horizontal asymptote. So without taking limits, as x approaches infinity and negative infinity, by just using these shortcuts, we can figure out what the horizontal asymptotes are. Let's take a look at some exercise questions in the book. Exercises 3 to 6. We're asked to match graphs with the functions. First function, f of x is equal to x over x squared plus 1. What is the horizontal asymptote? Since the degree of top is 1, degree of the bottom is 2, then degree of top is less than degree of the bottom. Horizontal asymptote is y equals 0. So there is only one option whose horizontal asymptote is y equals 0. So it is D. We are done with D. Next one, x squared is the 2 is the degree of the top, 2 is the degree of the bottom. Degrees are same, so we just take the ratio of the coefficients, which are 3 at the top, 1 at the bottom. So y equals 3 is the horizontal asymptote for function 4. Y equals 3 here. In option B, we have the same horizontal asymptote. So answer to fourth one is B. What about 5? Degree of top is 2, degree of bottom is 2, y equals 2 is the horizontal asymptote. When you equalize denominators here, 2x to the fourth plus 1 plus x squared over x to the fourth plus 1. So 2 is the degree, 4 is the degree of the top, 4 is the degree of the bottom. Degrees are same, so we take the ratio of the coefficients, which are 2 over 1, 2. So we have the same horizontal asymptotes in 5 and 6. They are both 2. So what is the difference between A and C? There has to be a difference, right? How I am going to differentiate between 5 and 6? I am done with identifying asymptote, horizontal asymptote, but I couldn't find my answer because they both have the same horizontal asymptote. So what should we do? So to differentiate between them, we have to use point plotting. For example, let's take this A graph. It is passing through 0, 2, right? So which one is passing through 0, 2? Just try. When you put 0 for x in 5, what do you get as an answer? 0, 0, 5, 5. So it is not 0, 2, it is 0, 5. So fifth one is 4, C then. Sixth one, when you put 0 for x, you are going to get 2. So 0, 2 works for 6. So A is for 6, C is for 5 then. So after we determine the horizontal asymptote, we are between two options, then we use point plotting. Alright. Let's take a look at another ministry question. Which of the following is true for the function this? Domain is all real numbers. Yes, there is nothing that makes denominator 0, so no excluded number. The function is continuous at x equals minus 2. Yes, it is continuous at x equals minus 2. It doesn't make denominator 0. Horizontal asymptote is y equals 0. Yes, degree of the top is less than degree of the bottom. Horizontal asymptote is y equals 0. So it seems they're all true. All of the above are True, option D. Okay, another ministry exam question. Which one is the horizontal asymptote to this function? So unfortunately, we don't have polynomial here at the top. We have absolute value function. So the first thing to do here is getting rid of the absolute value. So we have to solve this question in a long way by finding limit at infinity for both positive and negative infinity, because there is absolute value, it is not polynomial. Okay, when I approach x from positive infinity, then inside the absolute value is positive, so you will take out absolute value x as it is, so it's infinity over infinity. When you apply L'Hopital's rule, it's gonna be negative 1. What about from negative infinity? 1 minus, when you put something negative inside, it will come out as its opposite, as negative x. So it's infinity over infinity. Apply L'Hopital's. We have 1 at the top, 1 at the bottom, 1. So it seems we have two horizontal asymptotes. Our horizontal asymptotes are y equals negative 1 and y equals 1. One of them will be in options. Option A will give you 1. Okay. We will either have both of them in the same option or one of them. Okay, let's take a look at another ministry exam question, 2023 second attempt. This is the given function, has a horizontal asymptote at y equals negative 2. Look at the degrees, 1 at the bottom, 1 at the top, so degrees are same. Then we're going to take the ratio of the coefficients, which are a at the top and negative 2 at the bottom. Negative 2 times negative 2, when you do cross product, it's 4. So we got the value of a. Now we need b, and vertical asymptote is given as 5 over 2. Remember, in a rational expression, after simplification, what makes denominator 0 is the vertical asymptote. So what makes denominator 0? So the first a is found by using horizontal asymptote. B will be found by using vertical asymptote. So we equalize the bottom, b minus 2x to 0, isolate x, x is b over 2. So this is our x, this is our vertical asymptote, which is given in the question as 5 over 2. So b will be 5. So we got a, we got b. Now we can calculate 3 f of a, which is 4, plus 5 f prime of b, which is 5. So let's write the original function first. This is what we are looking for. Let's write the original function. F of x equals a, which is 4x plus 3 over b, which is 5 minus 2x. That's the original function. In this function, I will evaluate it for 4, and I will also evaluate the derivative at 5. So I should take the derivative then. F prime of x equals, derivative of top is 4 times bottom minus top times derivative of bottom all over bottom squared, which is equal to, I'm afraid I will not fit in here. Over the bottom. So when I simplify it, I'll get 26 at the top, 5 minus 2x squared at the bottom. Now, let's evaluate the function at 4 and derivative at 5. Okay, first let's evaluate the function at 4. It is multiplied by 3. So that's equal to 3 by f of 4, 4 by 4 plus 3 over 5 minus 2 by 4, which will be, okay, 4 times 4, 16, 16 plus 3, 19, over 5 times 2 times 4, 8, 5 minus 8 is minus 3, 3's cancel each other, negative 19 is the value of the function at 4 and it's multiplied by 3. What about the value of the derivative at 5? 5 by f prime of 5, which is 26 over 5 minus 2 by 5 squared. So that's 5 by 26 over 2 times 5, 10. 5 minus 10 minus 5 squared, 25. Simplify. It's going to be 26 over 5. So I got negative 9 and 26 over 5. I'm supposed to add them up, right? So let's add them. Negative 19 plus 26 over 5. We need to equalize denominators. I have 1 here to make it 5. Multiply top and bottom by 5. So here I'm going to have negative 95 plus 26 over 5, which will give me 69 over 5. Negative 69 over 5, which is option A, right? So this is pretty nice question. In the same question, they ask the horizontal asymptote, vertical asymptote, and taking derivative of the quotient, evaluating functions. There are too many topics combined in one question. Okay, let's continue with finding horizontal asymptotes. If there are two different horizontal asymptotes, generally the questions involving radicals, either having radical at the top or radical at the bottom, we will have two horizontal asymptotes. So you will see these two kinds of radical functions. You'll either have radical at the top or radical at the bottom, and when you take a look at the degrees, you'll see that degrees are the same. Degree of the top is 1, degree of the bottom when you remove the radical is also 1, same degrees. So we will basically take the ratio of the coefficients, which are a at the top, square root c at the bottom. If we approach limit from negative infinity, then there is negative in front. If it is from positive infinity, there is positive in front. Okay, it doesn't matter where the radical is, it's always the ratio of the coefficients. There is minus in front when the limit is from negative infinity, plus in front when we approach x from positive infinity. For example, in this figure, I see two horizontal asymptotes. The right side one, the horizontal asymptote as x approaches to the positive infinity is 3 over square root of 2. For the negative infinity, it is negative 3 over square root of 2. Let's take a look at some examples and see how to identify asymptotes. Find horizontal asymptotes. So we will have two asymptotes, one for positive infinity, one for negative infinity. For positive infinity, we'll have positive in front. For negative infinity, we have negative in front. Just write the ratio of the coefficients, which are 5 at the top, square root 3 at the bottom. That's it. That's pretty simple. But when you solve the questions, do not jump into the question and write the coefficients immediately. Just check the degrees first. Maybe degrees are not same, then you don't need this. Okay, so make sure that degrees are same first. This was check it out question. Now the next one is a ministry question. It is giving you the value that x is approaching. We are approaching x from negative infinity, so you will have negative in front. Negative. The ratio of the coefficients. Coefficient at the top is 1. Coefficient at the bottom for x is 3. So negative 1 over 3. It's pretty simple. It doesn't require any solving. You immediately answer the question. What about this? Can we do the same? Can we say it's negative infinity, so negative in front, coefficient at the top is -2, at the bottom is 1. Can we do that? We cannot do that because degrees are not same. So we have to be careful. Degree at the bottom is 1, while degree of the top is 0. There is no x at the top. So we cannot use this. So remember the fast ways. If degree of the top is less than degree of the bottom, then horizontal asymptote is immediately y equals 0. So we can say the value of this limit as x approaches to negative infinity is 0. Okay, it's not asking about horizontal asymptote, it's asking about the value of the limit, so it is 0. So we can still apply this fast ways when it is asking about the value of the limit. It doesn't have to ask about the horizontal asymptote. The same applies for the limit questions too. Okay, one last question, and I'll finish. I'll close this horizontal asymptote topic. Okay, a figure is given in this question. It's asking about horizontal asymptote. Is it 1 when x is approaching to positive infinity? It is 1 when x is approaching to positive infinity. No, x is not approaching to positive infinity. The graph is passing through the horizontal asymptote heading up. It is not approaching to positive infinity. There is no approach. But there is approach on the left side. Look at the left side. The graph on the left is approaching to this line, the horizontal line, when x is approaching to negative infinity. So be careful. This part is not heading towards to positive or negative infinity, but that part is approaching to negative infinity. Then function is heading towards y equals 1. So negative infinity. So this is the answer. Option B. Y is equal to 1 is the horizontal asymptote. We have this situation when x values are heading towards negative infinity, not positive infinity. Okay, if we had such graph, let's say, then we would say that x values are heading towards positive infinity, then function is heading towards 1. But right side of the function is not approaching to 1. The left side of the function is approaching to 1, so it's heading towards negative infinity.